Today we are going to see about system calls and system programs. So what is a system call? System call provides the interface between a running program and the operating system. So whenever a program wants to be searched inside a memory, so a system call command is going to execute and fetch you your program. So generally available as assembly language instructions. So those system calls cannot be understood by the user or a programmer because it's a system generated zeros and ones. So it's like a assembly language instructions which cannot be understood by normal programmers. So languages defined to replace assembly language for system programming allow system calls to be made directly. So with the help of C and C++, nowadays we are doing the system calls very directly using C programming language command and C++ programming language, which can be understood by the programmers. So the three general methods are used to pass parameters between a running program and the operating system. Pass parameters in registers. Store the parameters in a table in memory, and the table address is passed as the parameter in a register. Push or store the parameters onto the stack by the program and pop off the stack by operating system. So generally, the informations are stored as a stack. So stack is a first in, first out concept. So a table which contains the data in a way that the operations takes place, but whichever value comes in first, that will be taken out first. So either you can use the stack or you use the operations inside the stack with push and pop. Push is for entering values into the stack, and pop off is for getting the values out of the stack. Or even you can pass the parameters in registers. So we have registers. So using those registers, you can pass the parameters, or you can store the parameters as a table, and the table address will be passed as a register. So passing of parameters as a table. So how will it works? This is the diagrammatic representation. So X is a parameters for call. So the command is going to be system call command is going to be load address X, system call 13. So therefore, when it executes load address X, so this will find the register which contains X, and then that register will have the parameters from table X. Use the parameters from table X. So this is the system call 13 command. So once you load the address register, the system call 13 automatically uses the parameters from the table X. So this is the code for the system call 13. Use parameters from table X. So for that, we need two commands. One is to load the register first and then use the system call. So now from this, you can understand that the user program gives the system call and also the commands. So automatically the operating system will do the code or the work corresponding to the system call numbers. So system call will be represented as numbers. So for each number, you have a separate code. So the types of system calls are process control, file management, device management, information maintenance, and communications, which means when you do the process control, the system call will be generated. And when you do any file management, system call will be generated. When you do any device management, system call will be generated. Whenever you do any information maintenance, so everything is passed as a system call. So when you communicate between the memory, between the OS and CPU, definitely you need to use the command, and the command will be taken as a system call, and the system call code will be generated for the corresponding number that you have given. That particular code gets executed inside the operating system. So this is nothing but a communication what you are giving between the user and the operating system. The operating system is a program which knows only zeros and ones. The user knows only programming languages. So he gives command in a programming language that will be converted as a system call. That's for every command you have a number. So when you use that number with the system call, automatically the code represented for that number will be executed in the operating system. And MS-DOS executions. How MS-DOS, Microsoft Disk Operating System, executes is whenever at the time of system startup, so there will be kernel inside the operating system. You will have a command interpreter and some free memories where you can load and share your files. And at the time of running a program, there will be kernels, command interpreter, and process that will be stored inside your operating system. And it takes some spaces, and some more spaces will be as a free spaces for the user to load some other process. Unix running multiple programs. So how the Unix will look like, or how what are the uh, what is the actual scenario inside the operating system when Unix runs the multiple programs. So it is going to have the kernel that is loaded already, and you will have any number of processes and free memories according to the diagrammatic representation. 3 processes actually running, because it is a Unix is a multi programming language. So therefore, 3 processes are executing at the same time, B, C, D, and you have some free spaces and also the interpreter. So what is the work of an interpreter is to read each and every line of the command and execute that command. So what is communication model? So how in communication models actually the process happens is the communication takes place either message passing or shared memory. So in message passing, you can see it in the diagram, process AB and kernel is there in the operating system. So M is the message passed from process A. So the load M, so M will be loaded inside the kernel, and process B, what it contains is getting back the M, the data M, or it could be an address for a register. So whatever it is, so the M will be again taken from the kernel to the process B for further execution. So this is how the communication takes place as message passing. What is the shared memory is? Kernel will be there, 2 processes is executing at the same time, but the memory is same. So therefore, the process A also share the same memory, and the process B also share the same memory. So from process A, M will be loaded into the shared memory, and process B will take the M from the shared memory and executes it. So these are the 2 types of communication models happens in system calls. What is system program? So system program provides a convenient environment for program development and execution. This can be divided into file manipulation, but all the files creation, uh, execution, domination, everything happens as a system program. Status information, so any information when you pass, that will be taken as a system program. So what is a system program? System programs will be in zeros and one, that is machine understandable language program. And file modification, so whatever you do in the files, that values will also be modified as a system program only. And programming language support, so in whatever programming language the user writes, that will be automatically converted into a system program, that is user understandable program, that is assembly program. Program loading and execution, all the commands will be taken as a system program. Any communications, that will be written as a system program, and then only it is communicated. All the application programs will be converted as a system program, then only it gets executed in the operating system. So most users view of the operating system is defined by system programs, not the actual system calls. So the difference between system calls and system programs is system calls will have a command, will have only a single command, that for every number represented for the system calls. But in the system programs, you can have a number of lines of code to be executed by the operating system. So that is the only difference between system call and system program. Anyway, both the system call and system program is going to execute the command or programming lines what you have given for that for execution. MS-DOS system architecture. So the structure of the MS-DOS system is to provide the least space, the most functionality in the least space. So even though you have a less memory, in that less memory, MS-DOS commands will work. That means you can create a file, create a document folder. You can store any number of files inside any documents or any folders, and you can give permissions to all the files. So everything you can do within a least space, not divided into modules. The MS-DOS has not been divided into modules. When you go for Windows structure, it is divided into modules, that is C drive, D drive, like that. Everything is divided, the partitioned in Windows. Although MS-DOS has some structure, its interfaces and levels of functionality are not well separated. So both interfacing is the user entering the commands, and the execution of the command happens at the same space in MS-DOS. So MS-DOS layer structure is in the end you have a ROM, BIOS, device drivers, the basic input output system, and read-only memory, and MS-DOS device driver. So first, the application program will be written by the user, and it is converted it as a resident system program, or directly you may access the application program by the device drivers, or it can be converted as a resident system program, and the MS-DOS device drivers will access those application program which is converted as a system program, and it will be sent to the ROM, BIOS, device drivers to get executed. So this is how the MS-DOS layer structure works. And Unix system structure is, it has the limited hardware functionality. The original Unix operating system had limited structuring. The Unix OS consists of two separable parts. One is the kernel, another one is the system program. What is kernel is everything below the system call interface and above the physical hardware. So the kernel is also it is a heart of your heart of the operating system. So without the kernel, the operating system will not work. Even though if some applications are not running, the kernel has to run continuously until you shut down your processings, and provides the file system, CPU scheduling, memory management, everything. Every operating system functions a large number of functions for even for one level of programs, types of programs you use. So all the facilities that will be given by Unix system structure. So file system can be maintained, memory management can be maintained using the Unix system structure itself, and other operating systems can be executed, and the CPU can also be scheduled by the system structure of Unix. So this is how it looks like. So in the beginning, you have the users. The user will give a command in a Unix language. The shells and commands, compilers and interpreters, systems libraries comes under the second phase. And in the third phase, you have the system call interface to the kernel. So all the commands, all the programs, whatever you write in shell, whatever it is, compilers or interpreters, everything will be converted to a system call interface, and then it is sent to the kernel. So the signals, terminal handling, character IO system, terminal drivers, file system, disk and tape drivers, CPU scheduling, page replacement, demand paging, virtual memory, every concept is available in the kernel, in the Unix system structure. So everything will be converted according to the understandable concept of Unix operating system, and the kernel interface to the hardware. So the kernel will have the system call and system call. So that system call will be executed by the kernel, and any interface between the hardware needs to be done. That also happens with the kernel interface to the hardware. So what are the hardware devices you can use in the Unix system structure will be terminal controllers, terminals, device controllers, disks and tapes, memory controllers, and physical memory. Layered approach. The operating system is divided into a number of layers, each built on top of lower layers. So you have lower layers and also higher layers. The bottom layer, that is the 0th layer, is the hardware, and the last layer, highest layer, layer N, is the user interface. With modularity, layers are selected such that each uses functions and services of only low-level layers. So everything is based on the working of modules, working of layers based on the modules. So it uses the system functions and services for only lower level layers. So all the system functions can be used for executing from lower level layer to higher level layer. So everything is a module divided as a modules. An operating system layer. So you can see here new operations or existing operations. So if the existing operations is in a layer m-1, it also contains some hidden operations which are not known by all the people. So everything is in layer m-1. When new operations comes, a new layer can be created, and the above the m-1 layer, and that is the layer m. So every new operations will be stored in the above layer of the lower level layer. So any number of layers can be created in an operating system environment. Thank you, students.